Hello. In this video, we're going to go ahead and look at an application. It says find the linear velocity in feet per second for a point on the equator. Alrighty. So, if you didn't watch the last video, on the Earth, it has a radius of 3,950 miles. Okay. And we figured out the linear velocity that way. Now, again, you can just refer back to the previous one, but omega is pi over 12 radians per hour. But notice something, we can actually rewrite this. It is pi radians for every 12 hours. Now, the reason I'm doing this is because if we look at the linear unit that we want here, the linear velocity unit, it wants it in feet per second. Now, the time unit needs to be in seconds, not in hours. So I need to convert this. So notice that for every 1 hour, there is 3,600 seconds. So the hours would cancel, and this would give us pi over 12 times 3,600. What is 12 times 3,600? Well, that's 43,200. So this would give us pi over 43,200 and then radians per second. Good. But notice that we want the linear velocity in feet per second, not in miles per second. So what we need to do now is we want to convert R. R is in 3,950 miles. So let's convert that into, well, what do we want? We want feet. Notice that for every 1 mile, there are 5,280 feet. So the miles cancel, and multiply those straight across. That gives you 3,950 times 5,280. It's quite large. So this is going to become R is equal to 20856,000. In other words, 20,856,000 feet. Awesome. Now notice that it's feet per second now. We just multiply these two against each other. So it means that V is equal to R omega, which would be 20,856,000 feet times pi over, that's a weird pi, all over 43,200. And then just multiply this straight across and round, basically. So that, and then times pi divided by 43,200. Alrighty. So it means that this is in 1,516.69112, running to the nearest whole 1517 feet per second. So there you go. If you are standing at the if you're standing at the equator, you have a linear velocity of 1,517 feet per second relative to the axis of the Earth, basically. If you're just kind of going along with the revolution of the Earth around the sun. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.